or number 2, because 0, 2, 4 are the same really. But here, in order to you understand, he has put it this way. Again, if you want to understand the T, the word T on the table, we go to that base, which is number 4 in sitting room, which is the fireplace, and we say the T is a black thing and it's below left. Then that T is a table which has a top and it has legs, 4 legs. So in order to understand those, we come from number 5, which is the T itself. We go to number 6, which is the top part of that table, and we say it's a rectangle, it's horizontal, and it's on the above of the legs. So and if you want to see the legs, we go again to the T, which is number 7, and we come down number 8, and we say it's vertical and below of that T of the top. So what it says simply we put a reference and we see everything according to that reference. So we always have to go to that reference, come back. Without that, we don't understand what's happening where. So it's again like a coordinate system, but it's different. Now 3D or 2D, that's very important in again, our world, real from sensory equipment or entry which we have, we should know that the world, we see it 2D. We see it 2D. Our eyes only see 2D, no more. But we have 2 eyes. There's a difference between this 2D and that 2D, and from this difference, the mind creates 3D. So 3D is a software, is not a real thing. But what we experience, when I see it's there, I have to move there. When it's here, I can touch it. I see it's longer. It has shape up and down. It's different. So it's work together. The other senses we have, it confirms the same thing always. That's why we understand and we consider it real. So 3D is, the word of a 3D word is real in that sense, that it confirms everything together. Doesn't matter. So if everything works together, we can consider it real. Why not? But when it comes to physics, when we want to think of relativity or Newtonian physics, we have to be careful that this may not be true. This may not be true. We have to be careful that things are different. And that's why in reality, for example, in relativity, Einstein's theory, it says that the space can become distorted. Space, the way we know it, doesn't distort. Space is always 3D fixed. But in reality, in physics, maybe not true. Maybe space becomes smaller and become bigger. It can be. We have to know that our representation, our understanding of the 3D out is made of our mind. It may not be true physically. And that's why we also in Islam we have this concept of tayyul ard, and the word we use in our traditions, it says tayyul ard, means the space becomes rolled. Rolling space is something we don't experience it every day, but it may be real, so we have to be careful. In computer, what it does, it says that suppose we have a cube, this one in the shape, this cube, which side, the front side is A, and the 2 other sides, we call it side and top, S to the right and T on the top. So the parent region is the second datagram from top. If you see, the P parent region is a cube as a definition, but it's a cube that has been turned up 15 degree and side 15 degree. And part of it is squares. But what it sees the picture, the photo in the middle, which is 1, 2, 3, 4, 5, 6. 6, well, you can call it pentagon, but it is a 6-sided shape, 2D shape, the outside of the whole shape.
But when I close my eyes, I still see 3D.
No, you don't see.
I am seeing 3D.
No, you're making it. I mean, you're just making it. It's a memory. That's a problem. We can't take the memory out. You see, if you take a photo from your computer and you write a program to distinguish it, a boundary, for example, it can find the boundary. Again, this is another part which I didn't mention here. The boundary, how computers see the boundary, there are different algorithms. But the simple algorithm is just to see difference, change, sudden change in intensity or color. When it's intensity different, we know this is a boundary, okay? When we saw the boundary, that's what we understand. That's why the computer can understand. But the rest comes by definition. It can understand, but it's by definition. By saying that this side, S, is the same, A is 0, 0, is front if I see it. S is, I see it turned 90 degree this way, and T is tilted 90 degree. And so we just put more expense. But what we feel and what we understand is the memory. We have a lot of experience, and because of that experience, it remains in our mind that if you get even a smaller amount of data, you can guess. In fact, we are guessing. And more than that, it says in this computer that in fact, whatever we see as now, we think what it's experiencing now is not now. Because it takes time, first of all, to process in our mind, but it's more than that. It says it's what we expect to be, the short list, which I mentioned. So what we expecting that is happening now is the short list we are expecting to happen. And if it happened, okay, that's it, what we expected, nothing goes wrong, okay? But if it's something different, then we say, something changed. The same thing happens to to what you are hearing. If I'm saying the same thing, which you get used to it, okay, you just listen, simple, nothing happens. He's saying the same thing. But if something new happens, he's saying something I didn't know, then your attention becomes more, and you try to understand what he's saying. So it's for everything is like that. It's our mind uses the memory quite extensively, quite a lot, and that's what we do. On the matter of time, we all have an internal clock. So whatever happens, whatever sense we have, it puts a time on it. Simply like any file we create in the computer and whatever we do, always it stacks a time on it. And in previous Windows, on original ones, we could change the time because we could go to system and change the time. But I believe the new ones we can't do that. I believe, I'm not sure. Token datagrams have an attribute now that becomes active when the datagram's now status becomes active. So the concept of now is something special. Now, it's a tag, so it's a situation like priority. It's something connects to the datagram that is now happening now. But now is very narrow. It is not really philosophically now. Now it's a moment. For example, when we are saying that what is happening now in the world, we may consider 1 day, we may consider 2 days, we may consider a year. If we are talking about the history, for example, of the thing, so it's not absolute; it's a relative thing now. When we are talking about today, for example, things about days, to now maybe only 1 hour or half an hour or 10 minutes or maybe 1 second. But when are talking about an experience which very important to know the now, we may make it very narrow. But there is always a pixel. And now cannot be continuous. You can't have a now connected to another now. There's a gap because of our sensual system. We have limitation. And maybe that's the Heisenberg uncertainty, because it says that in our even experimenting, we can't get it. We are not sure about that. There is a discussion on quantum physics about it. That is this because of our instrument, or is it because of reality cannot have a small pixel? But what it says here, it says not only time is pixel, space is also pixel. So even space is not connected to each other. There is a minimum amount, which is that minimum amount, we call it 1 pixel. And of course, depends on your resolution of your camera or whatever you want sense. Resolution may be very high, but never will be infinite. So we have pixelation in everything, in time and space. Okay, And also in the movement, we cannot identify directly that a thing is moving as a whole. Interesting. We can only detect moving edges, and only one edge, not 2 edges. So if something is moving, if you see a cat moving, a table is moving, or even a small piece of wood or cube is moving, we only detect one side. We can't see the other side. But because we see both sides moved, and the next moment we see also the other side moved, so it's seconds or frames really. Maybe this is 1/20th, we see the beginning, and 1/20th the end, and we see both of them moved, so we say this thing is moving. Again, we have to be very careful about this matter, that we have limitations in our sensual system, that we only can check one edge, no other side. So in fact, that's what I'm saying, that if we want to measure even distance between 2 points, between A and B, it's not so simple as we think, that we just put a ruler. Even if we put a ruler, we have to fix the A and see what is the number next to ruler, and we have to go to the B and see what's the number next to the B, and then we see what's the difference. But that means we are doing it in 2 different times. And if we have a space form, if we call it, we are in I forgot his name, but anyhow, the space-time 4 dimensions, again, from A to B, when we move, we have spent time. We are not in the same place. So when we moved, so distance is not really a distance, it's time distance. And if we have time distance, we cannot measure. We cannot measure anything between 2 points. There is some problem with it anyhow, it would be. And how to put time is exactly the same as space. So we have, again, if we want to say previous and we have to say after, we have to go to the base point, which is now, and we can say if it's now, it was previous this event, or it was after this event, as we said on the table, that on the living room, that it has above or below or right or left. So the same thing happens, but for time.